All right. Uh, in this presentation, I'm going to talk about domain-driven design with behavior-driven development. Why using DDD? Basically, we use DDD to have a design common grounds between engineers in a very neat and tidy way. So basically, it's a design, and the engineers can advantage from this design so that they could develop faster and better and more efficient. But before we get to that, what is a domain? A domain is an encapsulation of all business logic in an independent, reusable component. As you can see in the picture, in the diagram or something, we have the domain here, and the domain is completely separated from outside world through ports. And these ports are basically interfaces. So in Java, we have interfaces, and through these interfaces, we either connect to the domain and ask the domain to do something for us, and the domain in turn can use the port, which is an interface, to basically connect to the repositories and make repository operations. But before we get into DDD and domain, we want to talk about BDD, to start with the tests. What is a BDD? What is behavior-driven development? It's a way of development, as the name says, to create tests by using plain English so that the business people can get involved in the development. What parts do BDD tests include? So basically, as we understood, it's using plain English, writing English sentences to come up with tests. So these English sentences would be basically translated into test codes. But what parts do they have? We have a given part, we have a when part, and we have a then part in our BDD scenarios. So what is given? In the given, we claim what data exists. It's like populating our database in the given. We basically populate our database to be able to use the data in our database in our service that we're about to test. When part is the part where you execute your operation for testing, and then the then part is basically the assertion to verify what you intended from the operation was actually done the way you wanted it to be. So basically, assert whether your service has done its job. So how does BDD test look like? So as you can see in this scenario, BDD tests are plain English, starting with a scenario. You give it its title, and then you use these given, when, and then to basically write your BDD sentences so that it would be very readable, especially by business people. The key note here is understandable and readable. So you have to write BDD scenarios in a way, and sentences in a way that business people can understand it. It should not be technical. So for instance, in this scenario, we can see, we say given John as a person. So basically we add John to our database and we claim that John exists in our database. And then we give a list of objects. By the way, and here is used as the same purpose as the last whatever you want to call it, the given, when, then. So if you say and after given, that means given, and then if you use and after then, that means it's a part of then. So we now claim that a list of jobs exists in our database: software developer, manager, and engineer. And when we operate, when operation find occupation of John is executed, so basically we're trying to find John's occupation, then expect operation find occupation returns that John is an engineer. So basically we want to make sure that our service returns the right job for a certain person. But there's two issues here. One issue is that the when sentence is not real, and also the then sentence is really not that readable. It's like operation find occupation. It could be stated in a different way. Also the then part. Maybe we can say, if we try to find the job of John, that would be a better sentence. It would be more understandable. Yes, so then the second issue with this is that we have not added a given sentence to say what job John has. So this is another issue with this scenario. So scenarios should be very understandable, very readable, and correct. And we'll get to how to construct a scenario in the best way possible so that it would be readable and very, very neat. So as we saw, the parts that the test include are given, when, and then. But how do we implement it? So as I said, there's a translation between the sentences in test code. This is how the translation work in Cucumber tests specifically. And Cucumber is normally used by Java. This is the annotation. This is a syntax of how to use Cucumber sentences. This is like you can use annotation at given, or at when, or at then to define your sentence, and you can use the brackets to define what type of data you want to give. So here you can have an example of it. For more examples, you can check out examples of Cucumber on the internet. That would be the best option. But you can have this as an example as well. So what happens exactly in the given part? So as you can see here, we have a scenario where we give John as a person and a list of jobs. So what happens is that we are populating the database here. And the database could be a normal class, an in-memory database that we use just for the purpose of testing. So as you can see, we have a set of persons, set of jobs, and we have operations that work on those sets, and we can use these operations in our repository operations, which in turn are used in our interfaces that the domain use. So what happens in the when sentence now? In the when sentence, we are trying to execute the domain, execute the operation that we have in our domain. And then the issue is that, as we said, the domain does not have it has access to the outside world through ports. In other words, interfaces. And then, but we really do not know what the implementation is until we implement it. So it can be anything. So we have an understanding of what our interface would do as a repository, and then we can do two things to test. One is to use Mockito, and the other one is to use to actually basically implement our interface. So with Mockito, we can mock the interface and say, okay, if you receive this data, then give me back or return to me this information or this data or whatever we intend that interface to do, that repository interface to do. So when the domain tries to ask repository through its port to do something for it, it can be mocked and it would return the right data given the argument that the domain has given that particular interface. But the second option is to have a repository port interface implementation. We can implement our interface, which is a better option because then you have full access to an in-memory database, which you can do a lot of manipulations in. Like for instance, if you have a service that use two separate services, and the first service creates a data on command in runtime, and the second service uses that same data that was created in the runtime by the previous service, then in that sense, using Moghito would be hard because the second service really doesn't know about what data was created in the previous service. But when we have an implementation of the interface, then we have to also have an in-memory database, and therefore, if any data was created in the previous service, then it could be accessible by the second service through the database, through the in-memory database. So then we have the then part. So we say then expect operation find occupation return John is an engineer. But what this does is that it will try to see if the return data from the domain is correct. But that's not all we should test. We should also make sure that we test whether the correct data was tried to be written in the repository. Why is that? Let's say we are trying to create a new data. Let's say we want to create a new order for a customer. Then if we create that order and we concoct this new order object, and we don't write it, we just return it, then we would get success in our assertion because we basically returned the right data, but it was never written. So we should, in fact, also test whether the domain has written the data in the database. So we have two options for that, again. So if we used Moghito, we could use argument captors in Moghito to capture the argument that was given in the interface parameter, and then check whether that data was correct. That means the next step is that the interface would be executed, and based on the given definition of that interface, we can assume that the interface will work correctly. And the second option here is if we have used interface implementation, then we can easily just check the database. And by database, I mean the in-memory database. So let's start with some BDD scenarios. So we can use test inputs or personas or any sort of data that we already created prior to this that we can use. Like for instance, we can say we have a user named John, or we have a user named Jack, and you can give an enum to this and use it in Cucumber to concoct your sentence. So as you can see, again, you used a given sentence for Cucumber to create a user, but then we can have this user as an enum and then use the full data for that specific user to use in our test. So here we have John. We already concocted a user, John. By the way, these data could be very big. It doesn't have to be just one attribute data. It could be a huge data. and then we can already use it. Normally, these are used as personas in different companies. Different companies have different personas just for testing to make sure that everything works correctly. They have the different scenarios in their personas to make sure that every different scenario in their business would be basically filled and used in the tests. All right. So now in our scenarios we can use and as I described it earlier. So after each sentence, whether it's a given, it's a then you can use and to indicate that this is a continuation of the previous step. You can use description. So for instance, here we have given user John, and when get a user with ID 123, then result is successful and John is returned. But there is a problem here. If we don't have the description, we really don't know if John's ID is 123. And I said earlier that John was already concocted, was already created beforehand as an enum, and we can use it, but we really don't know what the ID is. So 123 might as well be Jack. We don't know if it's doing the correct job. So we have to give it in the description that John's ID is 123, and John is rightfully returned if we are giving the ID 123 to our service. So for more concrete testing also, as I said, we can check if the returned result is as we wanted it to be, but we also have to make sure that the data that we wanted to create, for instance, is in fact created in a database. This is only in the in scenarios where we are trying to create a new data or update a data, not in the get scenarios, of course, not in the fetch scenarios. But then we can check whether a data exists. In this case, we can use the sentence and user John exists. And John, by the way, is a placeholder. As you saw earlier, John is a placeholder for a user. We can go back and you can see it here. It's an enum user. So John is basically user is a placeholder, and you can use John, Jack, whatever data you made for that placeholder. Okay, so we can use more readable sentences. So the problem with the scenario on the left is that we say given user John exists, but then at the end we also assert that user John exists. So these two sentences are the same. It would be a bit confusing what they will do since they are the same. So, but in hindsight, the first one, the given user John exists, claims that John exists in the database, but also the given John exists adds the data to the database, but then user John exists at the end claims that the user John exists in the database. So this should be changed. You can easily fix this by adding an expect in the beginning of the sentence. So you can just say and expect user John exists. And it will be more readable, and it will serve the purpose that we wanted it. It's basically we are trying to assert. So expect would suggest that we are trying to assert that this user exists in the database. We can also use data tables. You can see the syntax of how to create data tables on the internet. But this is how basically you create a data table. For readability of data tables, sometimes you get like very large data tables to create large data. Then if you use the data table horizontally, that would not be the best choice, even though using the horizontal way, you can have multiple rows. But if you do not have multiple rows that you want to give in your data table, then I would suggest using a vertical data table. What this does is make it more readable. You don't have to scroll to the end of the screen to make sure you see all the data. This way you can easily see it. As I said, readability of the cucumber tests, BDD scenarios, BDD tests are the most important thing. It should be very readable. But the problem, as I said, with this is that you cannot have multiple rows here or multiple data. You can have one data at a time, but the workaround for this is that you can use this sentence multiple times. But still, if you have more than 3 or 5 rows, then I would suggest to go back to the horizontal way of creating a data table. Testing failures. So we also have to be able to test failures. So here we have a scenario on the left, which is a success scenario, and the one on the right is a failure scenario. So we can just test for whether an error happens, and we can use the same logic with placeholders here as well. As you can see in the test error, we have the same logic. So what do we test in general? We test successful scenarios. We test functional errors. So what are functional errors? These are the errors that functionally happen in your service. For instance, something in your business logic that you don't want to happen, you test here. And then we have functional exceptions. You have to make sure that no exception that you don't want is thrown in your service. Or the ones that you want actually are thrown. Also with functional errors, it's the same way. If sometimes you want some errors that are thrown in your service, you want to make sure that those errors are thrown given a certain input. The same with exceptions. But you also have to check for technical errors and technical exceptions. Basically, these are the exceptions or errors that are thrown in the outside of the domain, for instance, in the repository part. And you want to make sure that your service is handling it correctly. So if some exception is thrown in your repository, you don't want your service to break, but to return a correct error regarding that issue that happened in the repository. So these are for the BDD tests. So we now have a okay understanding of what behavior-driven development is. But now let's move to the subject of DDD, domain-driven design. So what is DDD? It's a way of design with a set of technical and non-technical rules to solve domain-specific problems. But before that, we have to have an understanding of what bounded context is. Bounded context is a decision of how to split up responsibilities so it makes sense. Basically, it's a split up of responsibilities. That's it. But how do we split up the responsibility? As you can see, this model is actually one. So we have customer, order, cart, and product, and store and warehouse. But it has been split into two, and there's a connection here because between these two splits, and that's the product. And this is called context mapping. So we have split this work in a way that two separate teams can work on two different parts of your model. And then the part that produces data to the other part is called upstream context, and the other part is called downstream context. So So after knowing what bounded contexts are, we have to understand what aggregate root is, which is the most important thing that has been talked about in the DDD book. Basically, aggregate root is an object containing an aggregate of necessary data. It's an aggregate of necessary data to fulfill the intended business logic using the object's operations. So basically, we have a bunch of data that we need in a certain object, and we have operations, basically methods, in that object to operate on our data that we aggregated. And it looks something like this. It's basically a class containing the data that we need regarding our service or services, because we want to have an aggregate root so that we can use in many operations. And then we have operations that operate on these datas. But how to work with aggregate root? We have to read the aggregate data first, because the aggregate data is not following every object in a diagram, in a model. For instance, here we have a model containing customer, order, card, and product. But if we are trying to, for instance, do some operation, then we can have an amalgam of a couple of these objects in our aggregate root. So, for instance, if we want to make an order, we can get orders of a customer. We can have an aggregate root containing only customer and the order. Or if we want to find the orders regarding one product, we can have an aggregate root like this. And the root is the starting point. And as you can see in red, that would be the root. So if you want to find the orders of a customer, the customer would be the root of the aggregate root. If you want to find orders of a product, you can use the product as the aggregate root. But since the flow of the data, the upstream to the downstream, would be customer to product, if we have the customer as the aggregate root, we can have more operations done in the aggregate root rather than the scenario in the right where the product is the aggregate root, because the product is the downstream in this case. Sorry, by upstream and downstream, I don't mean the bounded context. I mean the flow of the association in the model. So the flow of the associations is from customer, because customer is using card and order and card are using product, as you can see in the arrows in the model. So the second part, as I said, the first part is read the aggregate data using a repository operation. We read all the aggregate data that we need. Then we do an operation on the aggregate data, and we write the changed aggregate data in case of update and create, of course. In the case of reading, we don't really need to write anything. We can just read the aggregate data, or even just have query services. We don't really need aggregate root to only fetch data. So how does DDD architecture work? So we have the domain, we have the repository, then we have the service, in one of our service at least in our domain, and then we have different operations, and we have our aggregate root, which is basically a class, and then the operations could access the operations in the aggregate root. So these are the methods in the aggregate root. Our operations, which could be classes, could access the methods in the aggregate root associated with that operation. So commands come in and operations are executed, and then we read the aggregate root data. So now the data is populated in the aggregate root, and then our operations get executed, and in turn, the methods in the aggregate root regarding that operation is executed as well, and then some changes happened in the aggregate root, and then after the change, we write the changed aggregate root to the database. So let's design an aggregate root. So we have a user story. Create an order for customer from their card and update ordered products stock amount. So as you can see in the model here, there is a stock amount for the model product. And we have to, when we make an order, we have to also make an update to that stock amount. However, let's not make into account that if the stock amount is 1, what happens in the race condition. We are not taking that into account. This is simply just for an example for seeing how an aggregate root is built, and we're not trying to dive into race conditions here. So how do we make our aggregate root? Our aggregate root would have the customer ID as a root, because we want to know what customer we are dealing with and fetch that data regarding that customer in our aggregate root. Then we want its cart, because we already have created the cart in our database, and it contains a list of product IDs, of course. And then we need a order attribute or field, which is initially empty, because we want to create this order first. And then we want all the products in the cart. And the reason I am creating, I'm making another, basically another field in this aggregate root for products extra to cart, is because I want to also update the stock amount. Given that, you can also come up with different ways of creating the aggregate root. This does not have to be the correct way, the best way of creating an aggregate root. This is the best that I could think about. So let's add, so now that we have this aggregate root, basically if we want to create an order, we fetch the data of the customer, we grab its cart, and then we have all the product IDs, and based on those product IDs, we fetch all the products in the cart, which is basically the 4th item. And then when we make our order, the order which was initially empty on the 3rd step, on the 3rd line, would be filled. And then when we want to write our aggregate root, now we have a new order, and we can create that order in our database. Now let's add 2 more user stories. Let's retrieve the history of customers' orders, and also update an order with a status initiated. So as you can see, there is a status. There's no status here, but yeah, let's assume that there is a status field in the order, and then the aggregate root that we want to create looks something like this. We still have the customer ID, we have the card, but now we have a list of customers' orders, because our second story will require us to return all the orders of the customer. So now we can have a list of orders, and then when we want to also create a new order, we can just add the order to this list and write it. However, we want to know what has been changed, so it's always good to give 2 information to the repository when we are trying to write our aggregate root. One is the previous step of the aggregate root, the snapshot of the initial version of our aggregate root, and one data that we need to send is the changed aggregate root. So if the repository have these 2 information, these 2 datas, then it can decide whether an update is happening or not. So basically here, we can also make a change. We can have a list of customers' orders, and also another field called order, which is basically the order that we want to create. That's also another option to bypass this, but still the best way, good practice, is to always give the snapshot of the initial version of aggregate root, and also to change the aggregate root to the repository, so that the repository can decide how to write it. For the third user story, we can also update the status in our order as well. So this aggregate root is capable to do that as well. So this is how we design in DDD and how to test it. There is a workshop that you can use this link, and the branch is also there. You can use that, and in the workshop, it is explained what to do. But what you need is a working computer. You need JDK, Maven, IntelliJ, and Cucumber for Java, IntelliJ plugin that you need to have. And then this is what you need to do when you go to that branch in that repository. You can pause this and do the steps as defined in here and in the repository on GitHub. Thank you very much. This was fun. I hope you guys have enjoyed this presentation and it was useful. Thank you.